I'm looking for somebody who can be an evangelist for Epic Games in Russia. Well, basically in Eastern Europe, covering Russian-speaking countries. I'll get into that a little bit more in a little bit. So I've never actually worked with a live interpreter before, so if things get weird, you guys, it's not a big room. There are not very many people here. Just wave your hands and ask questions. Just so I know, who here has some English language skill? Yep, developers is pretty common. Yeah, okay. So help out. If something seems a little bit weird, just let us know. I have a quick little feature video that I'd like to lead with, and then I'll get into the slides and proper introductions. But this is that Hollywood sizzle that people expect out of Epic Games. Okay, so that was a nice little feature reel. So my name is Andy Hess, and I am an evangelist, actually building an evangelism group for Epic Games. And believe it or not, I'm not much of a Windows user, so bear with me when I figure out how to hit play on this freaking thing. Where's the go button? Seriously, where's the go button? There we go. Oh my God, Microsoft, terrible. Okay, so as I mentioned, my name is Andy Hess. I run a group called Evangelism for Epic Games. My background, I've spent about 20 years in the game industry, mostly on the technology platform side of the business. I've worked for companies like NVIDIA, Aegea, Do you guys remember Aegea? They created PhysX. You're familiar with that? So I invented the name PhysX. That is, thank you. Thank you very much. Yes, that is my enduring claim to fame. I invented the word PhysX. So next time you're cursing the rigid body simulation, you can think of me. About 9 years ago, I worked at Apple, up until about 3 years ago, doing games for iPhone. I was responsible for developer relations and outreach for iPhone. So I've been around a little while and have done some interesting work. And this opportunity at Epic came up to move over to the software side, to the content side of the business, and I thought it would be really cool to try that. I'm good at building programs to engage developers, and that's what I'm trying to do in new markets for Epic. And so I'm looking for I'm just going to mention this a bunch of different times because people are coming in and out, but we're looking for help. We want to find somebody who is knowledgeable about game development, has a little bit of coding experience, and a passion for games and working with game developers, and loves Unreal Engine and wants to help spread the gospel of Unreal Engine. That's the origin of the word evangelism, right? It's a religious connotation, but spread the gospel of Unreal Engine. Because I need help. I'm a business guy. I did a little bit of coding 20 years ago when I got out of college. My skills are incredibly rusty, as you'll see when I attempt to demo Unreal. Just want to preface that. Please don't laugh at me too hard. You probably know more about Unreal Engine than I do because I'm the business guy here. I'm looking for a technical evangelist out here in Eastern Europe. Did I mention we're hiring? And that person's responsibilities would be to engage Russian-speaking game developers, get them excited about UE4, help them transition to UE4, and then help Epic understand what this marketplace is like. Who's doing the cool work, who's really pushing the engine, who needs help to ship their games, who can we work with to be partners in game development moving forward. This person's going to have 7 to 10 years of game industry experience, 5 years of actual development experience, maybe 5 years of business or marketing experience. That'd be a nice package. Some programming experience, but it's not an engineering job. You have to understand how C++ works with the engine. You have to have the basics of C++ programming. You have to understand how the IDEs work, et cetera, but it's not an engineering job. An engineering background is preferred, but there are a lot of artists and designers who know a little bit of programming that would be suitable for this job as well. Willing to travel. We want to meet game developers, so whoever we hire needs to be comfortable traveling maybe 50% of the time. Of course, we pay for everything, for that travel and entertainment, but you'll be going to all the game dev centers in Eastern Europe, from Moscow to Kiev to Minsk and so on. And then this is important, great English skills, because I have zero Russian language capability myself. So when we're communicating, across vast distances, I really need to have a strong English speaker so we understand what's going on. So enough of that for now. Now that the advertisement's out of the way, help wanted, we're hiring. So a little bit about Epic Games. Well, before I start with that, a question about you all. Epic Games is based in the south of the United States, so we say things like you all, y'all. But before I get into that, how many here are programmers? Okay, more than half the room, that's great. Artists? One artist, fantastic. Designers? Producers? Okay, mostly programmers, great. My C++ skills are terrible. They're about as bad as my Russian skills, so maybe one of you can help me out. But another quick question, how many here have some experience with UE4? You've actually downloaded it and you've started building stuff in UE4. Great. So this is Introduction to Unreal. It's Introduction because that's all I'm qualified to teach. I'm looking for people who have more advanced skills than me to go and teach other game developers. That could be one of you. But that's great. People learn something new every day. I was hoping there might be more artists and designers in the room because UE4 is a great tool for that. But that's okay. So who here uses Unity? Okay, perfect. You're the guys I want to talk to. We think this is a great option for you, and hopefully you'll be convinced by the end of the day. So Epic Games, we've created many great gaming franchises over the past 20 years. Unreal Tournament, Gears of War, Infinity Blade for mobile. We're working on Fortnite, and we've announced Paragon. Paragon is just a spectacular photorealistic, MOBA that is played in the third person. And having been in the game industry, in the graphics industry for 30 years, people have thrown the word photorealistic, real-time 3D graphics around for 20 years, and it's been bullshit until now. I honestly believe Paragon is the first time you could credibly say that an action game for the computer is photorealistic, and I'm pretty excited about that. Unreal Engine, for as long as Epic has existed, they have licensed Unreal Engine. So we have 20 years of experience working with developers to help them use our technology. In the past, though, the technology was very, one-dimensional. If you were building a shooter or a cover shooter, a dungeon crawler, something like that, Unreal Engine 2 and Unreal Engine 3, they're great products for that. But if you want to build a strategy game or a flight simulator or a card game, for crying out loud, Unreal Engine probably wasn't the best choice. We decided, and it wasn't inherently cross-platform, it was very Windows biased. It wasn't suitable for mobile or web, it was just way too heavy. And it was complex to use. It's probably fair to say that Unreal 2 and 3 were an SDK with a few art tools. And it was pricey. If you wanted to license Unreal Engine, it was many hundreds of thousands of dollars, if not millions of dollars, to ship your AAA title, and that was our focus. Well, all that changed with the advent of mobile. Mobile exploded onto the scene. Everybody wanted to be on iPhone, and Epic was a little out of position. The technology was too heavy for mobile. They had plans for Unreal 4, but they hadn't gotten very far, and that created a vacuum. In fact, kind of a funny story. By the way, I love Unity. I love the guys at Unity. My first day on the job at Apple 10 years ago was the week that Apple had their developer conference, and I was asked to go to the airport and pick up this developer who had an interesting game engine package for the Mac, and that developer's name was David Helgeson. And even then, he popped his collar. So he's always done that. He's a great guy. It wasn't just his fame and fortune that led to that. He's always been a little bit interesting like that, but he's a great guy. David had no money back then, and I drove him. I thought I would take him to a hotel in San Francisco. He couldn't afford a hotel. He was staying at a friend's house and sleeping on the couch. So I love those guys. I worked with them all the years I was at Apple. Super great company, super great group of people. But we have a slightly different focus, and people like to make drama about it, but really it's a small industry and everybody likes working with each other. So back to the present. So with Unreal Engine 4, we wanted to build something that was easy to use for artists and designers. It was a complete tool set with a visual editor and sort of an integration that allowed all those different systems to talk to each other. We had an inherent multi-platform focus. That's why we use C++ as our SDK. That allows us to be everywhere, right? So that you guys can choose what platforms you want to be on. It's basically born for VR. When you think about, I'll get into this in hour 2 or hour 3. I have a section on VR, but in a nutshell, you guys know this. VR, it's about visual fidelity and performance. Visual fidelity because that's what immerses you. That's what makes it, virtual reality. And then performance, that's what prevents you from getting sick. And nobody wants to have their customers, throwing up on your software. That's just not fun. So visual fidelity and performance, those are two things that Epic has been very, very good at for the past 20 years. Industry-leading graphics and rendering. This is what we're best known for. Really Hollywood quality visuals, global illumination, high dynamic range lighting effects, various lighting paths depending on what you want to do. This is handy if you're at a high-end PC, you can do a fully deferred render, but if you're going mobile, you probably want to do a forgive me, I'm also jet lagged, but the opposite of a deferred render. Lots of great post-processing effect, motion blur, depth of field, reflections, ray trace shadows, glow effects, the list goes on. In terms of usability by all disciplines, we developed a scripting system called Blueprints. And Blueprints is a visual node-based way to control our game framework. Basically, every every API that's in the C++ SDK is exposed through blueprints. You can declare variables, you can set up arrays. We manage all the garbage collection in the background. It's basically programming for non-programmers, but it's very accessible to artists and designers. I'll be showing that in a bit too. And it's fully integrated with C++. So at any time, you can move between the Visual Blueprints editing system and C++. You could subclass from any of our classes, in Blueprints and decide, hey, well, this is getting more complex than I thought. So then you could basically resubclass and create a C++ class and have your C++ class, pass information back and forth to other classes that are implemented in Blueprints at will. The other nice thing about, so one thing, for the C# programmers in the room, how many here have training in C++? And how many, I love Russia. The computer science training in this country is superior, I think, to just about any other country I've ever worked with, and that's been the case for 20 years. We were always blown away. Nostalgic, but when I was at NVIDIA in my early days, that's when games like IL-2 Stromovik were coming out and Stalker, and we were just constantly amazed by the work that was coming out of this part of the world. But anyway, if you're a C# programmer, or any of the Unity guys here C#? Okay. So if you're working with the Unreal game framework, we manage memory. We do all the garbage collection. You don't have to deal with pointers. You don't have to allocate memory or do any of that kind of stuff. You're effectively scripting using C++ syntax at that point. You can think of it that way. And it can make it very accessible for even web designers to build some stuff using C++ and Unreal. And of course, if you're hardcore and you want to bang on the registers of PlayStation 4, you can, because you have C++. You can inline assembly, you can link to whatever library you need to. Again, it might be a little bit more difficult in some ways, easier in other ways, but it gives you a lot of flexibility, and that's why we chose C++, and that's why we're sticking with it. So Unreal Engine's free to develop. We ask for a 5% royalty on your gross revenue when you ship your game. So if you make $1 million, we ask for $50,000. And the nice thing, and it's free for simulation use. So if you have a B2B application where you are developing a software package for a car company or an aircraft company or an architectural visualization type thing, it's free for that use. If you're making films with it, it is free for that use. If you're just making something, we have an interesting spinning car demo. You probably saw the example of that in the video, this time with McLaren. Again, another nostalgic thing. I've been in this industry in the graphics industry for 20 years, and every year there's a better spinning car demo. It's even shinier with even better paint and leather interior and that new car smell. It's amazing. So the question is why did we make this free for all developers? The answer is we're developers. We're game developers. We know it's really hard to make a good game. It takes a lot of time. It takes a lot of investment. And especially today when there's so much competition amongst game developers, it's risky. You can spend a lot of money making a game and you don't have a guarantee for making that money back. So we decided to make it free for you to develop, so hopefully you'll be successful and you'll make a lot of money and give us 5% of that. But if you're not successful, it can happen sometimes, you're not out any money. We don't want to take your money if you're not successful. Our motto is, Epic is successful when the developer is successful. That guides our planning and our philosophy. It guides prioritization. If we see showstopper bugs, on the part of a game developer, well, he's not going to ship that game. He's not going to make any money until we fix those bugs. So that becomes our priority. If there are new features, VR, everybody wants to do VR. Well, if they need VR to be successful, we're going to focus on that to be successful. We still do custom licenses. There are a lot of publishers that just don't like royalties. They don't like the unknown variable of how much money they're going to have to pay. Publicly traded companies are frequently like this. But also, one size does not fit all, and some business plans need some flexibility. So The difference, I'll talk about our support options in a little bit, but the free version of UE4 is supported by the community. There are Epic employees that monitor things like Answer Hub and our forums, and if the community can't find an answer for a problem, Epic people will step in, but that might take a little while. If you have a custom license, you are guaranteed support by Epic employees, in a quick turnaround frame. So if you have a big publishing deal, you really want to talk about a custom license because that's going to help you guys ship the game as fast as possible. So goals for this session. So we're going to provide a very brief overview of UE4. We're going to talk about the launcher and learning resources. If you're already using Unreal Engine, some of this is going to be very, very basic. You won't hurt my feelings if you go have coffee, but later on we're going to be showing some interesting stuff with an interesting explanation of the game framework. Even if you've been programming in it, you might not realize how some of these pieces fit together. We're going to be talking a little bit about materials, and we're going to be showing some interesting rendering technology that was developed for Paragon. And I also have a 30-minute presentation on sort of do's and don'ts, sharing some of the learnings that we have for VR. So if you want to gloss over the basic stuff and come back later, it's totally understandable. I won't feel hurt. Okay, so at this point, I'm just, getting back to community resources. We are working on localization in multiple languages, not just for the editor, but for all of our support resources and documentation. Until then, this is like a nice unofficial site that exists out here in Russia, in the Russian language. It's a great way to get some support. We can't guarantee the accuracy of everything they do. This is an independent effort. I just wanted to make sure that you guys were aware of it. All right, so getting into the launcher. So when you download Unreal Engine, the first thing that you're presented with is the Unreal Engine launcher. Basically, you sign up, you create an account, you download this launcher, and this is really your first step for news and information about everything that's happening with Unreal Engine. You'll see release notes, you'll see, our community support options like Answer Hub, our forums, the wikis, various blogs. You'll see, new content releases. This is where we shine a light on work that we've done and also developers have done, any hot fixes. This is a great way to start your day, drink coffee. It's better than the newspaper, certainly a lot less depressing than the newspaper. For example, there's a preview release of coming up, 4.12. There's going to be a lot of VR enhancements in there. If you were to read the release notes on there, you would see all sorts of great stuff. Learning in the launcher, this is kind of a big deal. A lot of people don't know this. This search bar is actually a Google widget, and it goes to a kind of search engine optimized version of, goes through search engine optimization to present Epic's UE4 content first. So if you have a question about how something works or what's going on, I encourage you to search here first as opposed to going to a web page and doing a Google search. Because this is going to scour all of our docs first, and then it'll go out to third parties that might have information about UE4. There's some great quick starts and tutorials here. For you Unity developers, we have a nice little guide. The cool thing about being a game developer is,
I'm sorry, the presentation is lagging.
Oh, it's totally broken.
Yes. Go get some to fix it later.
Oh, I have two monitors going on here. How about that? Look at that. Okay, let me fix that. Oops. Let's try that. How about that? You'd think after working at NVIDIA for 5 years, I would understand how to configure a monitor. But in all fairness, I worked for Apple after that for 7 years, and I lost all my PC hacking skills. Okay, where was I? Oh, that's not what I ought to look at quite yet. Okay, so just catching you guys up. This is a great this is better than the newspaper. Much happier information than what you see in the newspapers. Here's our Learn tab. You find documentation, links to video tutorials, and our community wikis. Great tutorials and quick starts. Introduction to blueprints, introduction to our various editors, content examples. And then UE4 for Unity developers. If you know Unity, you've already got a leg up because you understand the basics of a game engine. A lot of game engines do a lot of the same sorts of things. We might call it different, right? So in Unity, you might have a prefab. In Blueprints, you'll have like a Blueprints object. And this document will help you to understand those differences. A lot of our showcase demos we publish as learning examples. So a year and a half or 2 years ago, we did a demo called "A Boy and His Kite." Has anybody here seen that? Yep, great. It's a nice cinematic experience in an open world. So if you're building an endless world or open world type game like GTA or even an MMO, this is a great example on how to build a very large space with very few assets and leverage instancing and all sorts of great things to keep your performance and frame rate up. Talk about how to do water, how to do animation, and this is how Epic does it. And so we recommend you check this out as a great first start. A little bit about our marketplace. So our marketplace, we have a slightly different philosophy than other marketplaces. It is open for any developer to submit content. However, we do review that content for a certain quality standards. Things like, are they adhering to the Epic conventions for scale? We want to make sure that all objects are scaled in a real world sense. That is important when you're trying to do physically based lighting and physically based materials. It's important for VR. You find, I talk more about this later with our VR presentation, but when objects aren't scaled correctly, and if the textures aren't appropriate and it's too close to your face or too far away from your face, it can be disorienting in VR. And so adhering to real world scales is very important. For example, if anybody uploads an animation for a bipedal character, we want to make sure that that's dialed in for our standard bipedal character, which is 180 centimeters tall. An Unreal unit is a centimeter. It's the same thing. We also inspect content to see if the vertices are welded. We make sure that the textures are of appropriate quality, that all the bitmaps are there. If it's functional content, if it is a big blueprint class, we'll make sure that it works, that it runs. And that it's been vetted for readability, right? So sort of like a coding standard for blueprints, if you will. So you won't see hundreds of thousands of pieces of content. You will soon probably see about 10,000 pieces of content, but we feel really good about the quality of this content and that any developer could just drop it into their game and meet the quality standards of AAA gamers. So we're getting a little bit closer to the business side of things, but this is essentially the library. This is where I have all my projects readily available. I have versions of the engine going back to 4.9, and you can load at any point. I could bring this up and pull up older versions of the engine if I needed to. Say you run out of room on your system, you just want to blow it away. It's great. You can go back and get it later. I'm not going to install that right now, though, so I'll just close that. You'll see information about updates. There's an update available for 11, I guess, or no, I'm sorry, it's right here. So now we're up to Preview 3 of Unreal Engine. I do not want to press that button right now. Let's see what else is going on here, and that's about it for the launcher. So now I'm going to go ahead and fire up a project and go over some basics. Okay, so we'll take a look at this. So learning continues even with our templates. We have developed a variety of different game types of games here, game genres, like a first-person game, flying game, puzzle game, third-person game. These are set up the way all the rules, score systems, the game mode, all that's established. The control mechanisms for these types of games are established, and they're ready for you to essentially just start extending. You could swap out content. Let me just show you right now. So I'll bring up a project. I'll say, let's create a project with starter content. We'll go maximum quality. I'm just going to say, throw away, so I remember to throw it away when I'm done. I'll create a project here on the desktop. So I'm going to spend a few minutes here going over essentially helping you navigate this editor and talk about some of our naming conventions and help you get oriented. So across the top here you see different editing modes. This is just simply the object placement mode. You can access any placeable class in the game framework just simply by searching. If I wanted to find a directional light, for example, or a point light, I could go point light. Find a point light, drag that into the scene. Notice lighting, the live, its update. Everything in this editor window is live. There are settings. If you were to go to advanced settings here, not that, but you could go to window settings and adjust how this window gets updated. If you're working on a laptop and graphics are starting to slow down, for example, you could turn off real-time updates. So it would only update when you're either running your game or grabbing the mouse and moving your camera. So also with this, so that's, when you're dealing with placement, our widget system, it's sort of the, correct me if I'm wrong, but it's the max convention in terms of X, Y, and Z. We have, your snapping tools are up here. You can set, various snap sizes, get like big chunky snaps, or, and these are all in Unreal units, right? So 50 Unreal units would be half a meter. And that just helps you. I encourage you to download something called Keyboard Shortcuts. You'll learn nifty tricks like hitting the N key to, I can't do that yet. I just bring that back down there. But if I was to bring in clear that field, if I was to bring in just a random cube, and you could hit the N key, and it's not working. I don't know why it's not working. Okay, normally hitting the N key is a really cool way to just drop that down to the ground plane, and I don't know why that's not working right now. Let me just delete that object. Okay, so back to this environment. Looking at this rendering window, well, first off, at any given point, you can play your game. And so this is that template that I described to you. It's a kind of a third-person character template. What's in here is just enough smarts for this bipedal guy to go running around. It shows you how we set up lighting. It shows you how you set up animation. And you could start swapping in other models and other characters for this guy and start fleshing out a game. It's always live, always running. I could hit F8 and basically eject out of this. Oops, excuse me. We use WASDF for navigating, plus mouse look. And I'll go ahead and stop that. A little bit about this rendering window. We have your standard grids. We could go to kind of like a 4x grid. Go back into perspective for this one, and here we can make this the top view. So you've got all the tools to do that sort of thing. Go back to perspective. There's some other interesting modes here. You could, this is just the fully lit mode, but you can have an unlit mode. This is basically just showing, I believe this is just showing the, essentially the lighting textures on those objects, wireframe, all that kind of fun stuff. We can show shader complexity. There's not much going on shader-wise in this, but basically, green is good. If you start seeing, red objects, that means your shader's eating up a lot of GPU time, and you might want to take a look at that, or just go and smack your artist around because he did something bad. This is a fun one, just the buffer visualization mode. We have a variety of different visualization things. So if you're trying to debug lighting, knowing what your world normal looks like could be useful. Knowing what your scene depth looks like might be useful. I'll turn that back on to lit, and let's see what else we have here that's kind of fun. Various ways to visualize LED. Basically, you could force various. There's no LED going in the scene. It's very, very simple. But if you had complex LED, you could force, lower levels of LED for the entire scene and see what that looks like. Sort of a nice little trick there. Over here is our world outliner. So the world outliner, basically, it's it's searchable. I could find third-person character. Like there's my third-person character, and this hyperlink indicates. So this third-person character, let me go back a little bit here. So, you can also turn visibility off for all these things. They're still there. They're still in the scene. They'll still do collision. Oddly enough, though, things like lights, if you're working with a point light, for example, and you turn that off, that no longer is affecting the scene. So there are a couple quirky exceptions to that. But let me go back to this third-person character. You can see I select him on the outliner. It shows him in the scene. But if I was to click on this hyperlink, it's actually going to open up the blueprint for that third-person character. And we'll see essentially the event graph for movement, and you can look at the viewport for the mesh. You could kind of click on the mesh and go. Use this you'll find this little magnifying glass frequently in a lot of UIs. This will just basically find the content in the content browser, which is probably good to talk about right now. So this, all of your content will exist in this content directory. Notice when we fired up this project, we loaded a bunch of starter content. There's just a ton of fun stuff here to kind of get things going. For example, I have props. Like, hey, I can put it in a chair. And then if I was to run the scene, it's like, hey, that's a floating chair. That's amazing. And like, wow, I'm defying gravity. That doesn't seem logical. But now I can go and examine this guy, take a look at this chair, look at the details for that chair, and you can see that it's a static mesh component. So I'm going to talk about the Unreal game framework in a bit, but basically everything in a scene descends from a class called UObject. Everything that you can place in a game, be it a sound, a script, light, static meshes, dynamic meshes, animations, they all are actors of some sort. They all descend from the actor class. In this particular case, we've got a static mesh, which is our chair. I'm going to turn the gravity on for that guy and simulate physics. So we know that basically went from being a static object to a dynamic object, and now when I hit play, notice it just, I'll do that again. It was floating. Let's pick that up so I can really see that properly. So my camera is actually connected to this, that's not what I want to do. My camera is connected to this character, so I'll just rotate my character there. So now when I hit play, you can see great, physics is turned on. It's colliding with my character. I can make that breakable and assign it certain damage points, and it would know that based on the mass of my character against the mass of the chair, it would do a basic damage calculation. There's that physics kind of at play there, which is fun stuff. Where was I? Okay, so getting back to the Unreal Engine game framework. This is a good time to talk about that now, and then we'll get back to slideshow. That's what I want to do. Fucking Microsoft. All right, so here we go. We'll play from the current slide. So about the Unreal Engine game framework, we're going to go back and forth between the editor and this slide deck for a little bit here. But basically, when the game runs, basically the engine is going to load the game instance. And the first class it's going to instantiate is the game mode. The game mode is the rules of your game. It governs what player class you're going to load, what map you're going to load, other classes, which might be like the HUD that are actually showing some of the player state data and the game state data. It'll show your game state and your player state. It could include all the game rules and conditions. The game mode, if you're doing a multiplayer game, this exists on the server, which is important so people don't hack it. And it'll control all the information about your characters. Okay, so I talked about the pawn. Just skipping ahead here, this is a little bit odd. Yeah, okay, so remember I talked about how all actors in the scene descend from the U object. That's a basic building block in the Unreal Engine. An actor is anything that you actually instantiate in your game. A pawn is a subclass of an actor that is controlled either by the player or by AI, or other types of controllers that I'll get into in a little bit. And a character is a special type of pawn to specifically deal with a bipedal humanoid character. So it has rules about bipedal movement, and I'll show that. In fact, I'll do that right now. So let's take a look at our. For the Unreal users in the room, is this stuff like insanely basic, or is this helpful? Pretty basic? Few people helpful? So the people who have never touched Unreal before, is this useful for you? So far, just to help navigate? Okay, well, that's how it was built. We're gonna get into more advanced topics in a little bit. Okay, so getting back to our character class here. If you look at this third-person character, you'll see that he is built. Here's the actual instantiation of the character class. Okay, and if you look at the rules, you see that it basically inherits from the pawn class. We have certain components in here. We added a static mesh component for the geometry here. You would go in and examine that by digging in. You could take a look at, here's our mesh editor. This is where you would if you were going to retarget animation, for example, you could go in here and move pivot points. You could change the initial pose. This is the skeleton for the character. So if you're going to start driving this kinematically, that's how you would access that. Here is let's see, animation, and where is the physics? I don't think it's right there. So I forgot. I'll get back to that in a little bit. So here's our character class. This component here is a very powerful component, and that's where you essentially define how this character would move. I could adjust, what do I want to modify gravity? I can make him behave like, for example, if I was just to turn down this gravity, this might be good for a spot special effect. I don't know that you'd want to do this for an actual game normally, but you see now when I jump, he's got kind of like a man on the moon kind of thing, which is sort of cool. Going back to this character and his movement, we have rules here for walking. We can talk about his step height. So there's a little bit of logic that will drive this character when he's walking. You can tell it, like, you can step up on top of an object that is 45 centimeters high, but if I set this really, really low, let's just set this down to like 7 centimeters. I'll save that. Now when I when I hit play and I walk around, I don't know if I'm going to be able to get up on that. Well, let's see. Right, so I can't get up that, but those steps he can. But I could probably bring that a little bit lower and he wouldn't be able to step up on that. So you can define rules about how your character is going to behave in the scene. And then the Unreal Engine game framework is driving the character beyond that point. So let's go back to this guy. I'll put that back up at about 45 centimeters, I think it was. Walkable floor angle. I mean, this is, this would key into the animation system. If the floor became too steep, he would no longer stride like he was walking. He would have to like transition to some sort of a climbing thing. We have rules for jumping and falling, rules for swimming. What would be his max swim speed? And so basically, in blueprints, you would change the state. For the blueprint animation from walking to swimming, and it knows now that it has a swim animation and it's all part of the default package, and then that is the speed in which he can move. So it's fun to dig in here, and there are analogs for. Now remember, this character is subclass from pawn. A pawn is something that is driven by by either AI or the character. So a little bit later, we're going to be examining the vehicle class. So we have a four-wheeled vehicle, and it has a similar set of parameters that are appropriate for a wheeled vehicle. So there's just tons of, point I'm trying to make here is there's a ton of functionality that's just built into the tool and the framework, and you don't have to go to the store to buy basically a vehicle simulation. It's just built into the engine. So I'm going to close that. Where was I with the, so go back to this game framework. All right, so kind of we talk a little bit about how the framework is set up in that regard. Okay, so so a little bit about pawns. There's this one-to-one relationship between a controller and a pawn. And a character, the controller could be your AI or it could be the player controller. But an individual character could have multiple components, and I examined that a little bit. Something I should have talked about is this capsule component. And again, for the the Unity folks in here, when you dig into the character class here, this is another important component. Oops, look at the viewport here. So this is the physics capsule, or the collision capsule. So basically, this defines how it's going to sit on the ground, what it's going to collide with. It's optimized for performance, obviously. I could go and reposition this capsule and cause all sorts of problems, which you probably don't want to do. But if just to kind of give you a sense for how that might work, if I was to move this, well, let's see. Right. So if I, kind of position that capsule below his feet, and then I compile and save that, and we go back here and we just hit play, you can see, look, everything's normal, but not quite. But you can see how you might want to adjust the position of your capsule to change how your character interacts with the world. Let's get out of that. And let's bring that guy right back down there. Okay, so back to the game framework. The default pawn could also be accompanied by a spectator pawn. This is how you could drive a camera around the scene, follow characters after, in a death match after you died and you want to see all the other action. These are things that you could instantiate. I talked a little bit about the wheeled vehicle class that descends, that inherits from pawn, and that has things like a wheeled vehicle component, a static mesh component, a physics handle, and so on. That's appropriate for that type of vehicle. So, all right. So a little bit about so that we've discussed a little bit about the game framework, some manipulating some objects, a little bit about lighting. Let's get into blueprints a little bit. Let me delete that. And again, this is going to be a very introductory example. But what I'd like to do here is just kind of show you how objects that you would interact and then could talk to each other might be designed. So let's see, let me close that up. Okay, so I'll go to blueprints here. I'm going to create a new blueprint. And when you create a blueprint, it asks you what class do you want to base this blueprint off of. And we show some of the most commonly used classes here, but really any class in the entire game framework could be called here. And if I was to search this way, you could find that. For example, we have all of our special effects. Anything could be here, and you use that as a basis, and then you essentially subclass and modify from that. I'm going to do something really basic here. I'm going to make a floor lamp. Okay, now if I open up this new blueprint, you see we've got basically a floor just a reference object at the origin. It doesn't do anything. You call it the root of the scene. I'm going to go ahead and create some geometry for this guy. And so I'm going to add, let's see, a static mesh. Let's go and create a static mesh, and we'll call this we'll call it light geometry. And now we have the static mesh component, and if we take a look at the details, see there's nothing actually in that socket. There's no static mesh there. So remember I loaded some starter content. So I'm gonna do a search for something called a lamp. And we got this little ceiling lamp, static mesh. It's meant to be hung from a ceiling, but I'm gonna grab this guy and just rotate it around. It's gonna be a very simple example of how to create a floor lamp. Then let's see, underneath this root, I'm gonna add add another component. In this case, let's add a point light. There it is, point light. So now we have our point light here, and I'm changing placement modes. Oops, light bulb. So I'm changing the placement here simply by, why is that not working? There we go. So basically, R puts me in scale mode, which doesn't make any sense for a light. E will be rotate, W would be translate. It's similar to the Maya convention, I believe, but now I'm moving my light up in Z to get that kind of positioned in the, let me turn snapping off. Or just turn it way down. Okay, so I get that light kind of where it belongs on top of that floor lamp. And let's see, what else should I do here? So I'm gonna take this guy, and we'll say we're gonna have it cast a shadow. Now let's compile and save that. And so now, when I close that up, if I were just to take this guy and drop him in the scene, I have this, package, which is some geometry and a light. So it's starting to look like a prefab if you're a Unity guy. Okay, so that's great. Really simple. I'm obviously a terrible artist and not much of a programmer either. But I just put a light in the scene. But I'd like to interact with that light. So let's go back to this floor lamp construct, and let's add a trigger volume to it. So I'm going to go ahead and go back to the scene root here. I'll add a component called a box collision. So I'll just call this I'll call it my switch. All right, so now this collision component will create events when you collide with it, which is kind of handy. So if you look down here, basically I can say when something begins to overlap that component, boom, I get this event. And now we're in a new editing mode. This is the blueprint editing mode. And this is an event that I'll get from the engine, from the game framework. And let me go back a little bit to, get back to this viewport. Let me go to this light, bring this guy up. So the other thing, so this tag here, rendering, I can create a variable from this by, let's see, how do I do that? I'll go light. One of you UE4 users help me out here. How do I grab that handle for the rendering visibility? Oh wait, light. Apologize for that. I'm suffering from severe jet lag. How do I grab the handle for the variable for the light? So UE4 experts out here. In the graph. On the graph. Get light. But I want to know, let's see, is visible. There we go. Okay. So basically, all right, so when something overlaps this light, I'm going to set it. There we go. Toggle visibility. So basically, when we get an overlap of that trigger, I'm going to call this function, which is just toggle visibility. And the target is my light. So basically, I'm calling that instance of the light. I'm querying it for a property, and then I'm setting that light visibility. So now, and then before I do that, let me go and change this bounding box. So here's our light geometry. I'll go into scale mode. That's at the switch. And I'll make this have a trigger volume that looks about like that, maybe. Let's bring that out. File and save. Now go back to this map. So now you can see this trigger volume outlined here. The light is currently off, but if I play and I walk into that volume, you see basically it generates an event. It generates an event. That event calls a function. Here's the event. This is the line that's called the execution pin. That means call this function, which is toggle visibility on the light. This is a function that just knows, it's context sensitive. It knows that it's, this light, what functions are available for that light. One of them is toggle visibility, and it simply turns on the light. Now, that's cool, but we don't want to waste energy. So what we could do is going back to our viewport, let's take another look at that light switch. And let's say what happens when you end overlapping on that component. So we'll add another event, which is component end overlap. And we'll wire it up to the same function. So now if we begin an overlap, it's just going to flip the switch. And when we end the overlap, it's going to switch it the other way. Compile, save, boom. So back in here, I'll hit play. So now when I enter the bounding volume, it flips the light on, and when I leave, flips it off. So that's just the most basic thing that you could possibly do in blueprints, but we're showing a couple of important things. The concept of events, events that'll be, and different objects that you would place in your scene can generate different types of events. The option of a function, and then essentially setting a variable on another object, in this case, the point light object, which exposes, is visible. And so those are some just really, really simple concepts behind UE4 and blueprints and how to get started. A couple other things I want to talk about really quick, and how am I doing on time? All right, yeah. So lighting, there's, and this is going to be important a little bit later. There are a variety of different types of lights, and there's different ways to handle and manage lighting. One of the things that Unreal Engine is very good is in baking lights and putting them into lighting textures that get applied very seamlessly throughout the scene. And that's fine for your static objects, but if you do something in your game, for example, if I was to take this guy, this cube, and I was to, let's see, if I was to make this a dynamic object and simulate physics for it, so now basically this flag, it went from static to movable, and we're going to simulate physics on it. If I hit play, if I run into this guy with enough force and he's too heavy, so let me go back and change the mass. Yeah, of course that's 600 kilos, and my player character is probably only about 70 kilos. So let me turn that down to 50. So that's 50 kilos. Let's just save that puppy. And so now when we play and I just run into it with my character, you can see I can move it. Oh, but what happened here is the lighting didn't expect this object to move. And so we need to change a couple of parameters here in terms of the lighting. We're going to say, let's take a look at what this does. So it's creating a dynamic shadow there, but there's also this shadow that's been baked into the scene. So we're going to do some overrides here. We're going to override the light map, and we're going to. So this setting basically just changes how the lighting gets cooked. This setting is for dynamic features. So we just changed that, but how do we actually realize that? A very important concept is when you change kind of that cooked baked lighting, you have to do something called build the lighting. This is a process where the engine will go and calculate where all the light sources are. It'll do shadows, it'll do soft shadows, it'll do things like hello. Yeah, a second here. Oh, there it goes. I just need a little bit more time. So now, like, the bake lighting is gone, but our dynamic lighting is there. And this baking process, this was pretty quick. It's pretty simple on a single processor. When you have very large worlds with hundreds or thousands of objects, baking your lighting can take a long time. But we have a feature called Swarm that basically calls out to all the installations of Unreal Engine on your network or even on servers, and it'll start to basically run the baking process across multiple different CPUs in a parallel process to dramatically speed the lighting effect. Okay, so that's the super basic stuff. So now let's get into something that's a little bit more interesting. Let me go, actually, before I do that, let me go back to my agenda here and see how we're doing. That's not it. Where to go? Okay, so we've talked a little bit about the game framework. We haven't gotten into materials, that's next. A little bit about blueprints. So we could take a little break here if you guys are interested. And incidentally, I don't have 3 hours of content here. It's probably going to be more like 2 hours of content. We'll break a little bit early for lunch. But what I'm going to do next, which should be a bit more interesting even to you advanced guys, is we're going to do some interesting stuff with just a more interesting game. Maps. Okay, let me close that. Basically, we're gonna, I've got a neat little driving game here that we're gonna fire up, and I'm gonna show how to create a level for it and play around with our landscape tools. I'm going to build a fairly sophisticated landscape shader and some fun stuff like that. At the end, it'll look, stop that. It'll look basically like this guy when we're done. All right, so basically I'm going to show how landscapes like this, we're going to play with the foliage editing tools. We're going to play around with some more blueprints with these pickups. I'll explain how that stuff gets built. And all that will be after a 10-minute break. And so this is incidentally the game that we're going to create a new level for and a new terrain for when you get back.